Alright, second try here. Well, I'm glad to be back with you crazy cats here today. First of all, let's talk about the speed of light, c. Well, this is a rounded off number, but the speed of light is 3 times 10 to the 8th meters per second. And what we'll find out then is that that is its speed. Now, it changes a little bit relative to the material it's transferring or going through. But for the most part, it's still going to be approximately 3 times 10 to the 8th meters per second. I may have said squared earlier, but it's just meters per second. It's not squared. This is going to be the same in all reference frames. And what I'm talking about is, if you look down here, let's say that there's this vehicle, and it's going 15 miles per hour, and for whatever reason you decide to throw a baseball out of it, and you throw it at the speed of 20 miles per hour. Well, someone standing on the street sees the speed of that baseball as the 15 plus the 20, or they see the baseball traveling 35 miles per hour. Now, let's use this same analogy here for a person standing on a planet who sees a rocket going by, and out of the rocket, someone turns on a flashlight. Well, let's say the rocket is traveling at 1/2 c, or half the speed of light. And obviously the light would be traveling at the speed of light, or 1 c. So your first thoughts might be that they would see this as the speed of that light then as 1 and 1/2 c, because of the speed of the rocket plus the speed of the light. And that's not going to necessarily be the truth or the case here. They're going to see the speed of this light as being 1 c. There's nothing faster. So once it gets up to the speed of light, or I shouldn't say once it gets up to, but it's not going to go faster than c. It's impossible to go 2 c or have something be traveling 3 times the speed of light. According to different reference frames, they're going to just see it as 1 c. Now let's talk about down here at the bottom. E equals mc squared. Now this is a profound equation because it says that energy has mass and mass has energy. And this makes sense. You know, what do we do to gain energy? Well, we eat food. We're putting mass into our body. From that mass, we're gaining energy. Likewise, we have to put energy into food to get it to grow. If you, for example, a cow, you've got to feed that cow. You've got to put energy into that cow for that cow to gain mass. So it shouldn't be that big of a leap for you guys to understand then that energy is equal to mass times the speed of light squared. Problems with this. All right, so where does this come? In a nuclear power plant, uranium atoms split, and the mass of the resulting smaller nuclei is about 2% less than the mass of the uranium nucleus. If a 10-kilogram fuel rod undergoes fission, converting the missing mass into electrical energy, how much electrical energy is produced? Well, what happens here is when fission happens, we've got this mass, this nuclei, and it splits. All right, so here's it splitting here, and it's probably not a very good picture. And there was 10 kilograms of nuclei here. And what we find out then is that some of this mass, when it splits, there's this third component that's released. We have mass and energy. All right, so if you were to, after it splits, if you were to put these pieces of mass back together, it would not equal the 10 kilograms because some of that mass has been converted into energy. And it's that energy, all right, that they use in nuclear power plants to heat the water to create that creates the steam, which turns the turbines, which creates the electricity. So they had 10 kilograms, and they tell us that 2% of that is what goes towards the energy. So we got to find out what 2% of 10 kilograms is. That turns out to be 0.2 kilograms of mass. Well, if we go into our equation, E equals mc squared, the mass now is 0.2. C is still 3 times 10 to the 8th squared. And that tells us then that the energy that's put off here is 1.8 times 10 to the 16th joules. That's a whole lot of energy that's put off there. Alright, problems here. Alright, a truck with a mass of 22,000 kilograms goes from rest to 27 meters per second. How much does its mass increase? Hints here. Use kinetic energy to find the energy, and then E equals mc squared to find the mass increase. Well, let's do the kinetic energy. Let's find out how much kinetic energy it has. One half mv squared. Kinetic energy is going to be equal to 1/2 22,000 times 27 squared. Kinetic energy then is going to be equal to 8,019,000 joules is how much kinetic energy it is. So let's plug this into our energy equals mc squared problem here and find out, because you gained this much energy, how much mass have you gained? Well, that's 8,019,000 equals m, and then it's going to be 3 times 10 to the 8 squared. So we're solving for mass. How much mass did you have to have gained to gain that energy? And we find out the mass is equal to 8.91 times 10 to the negative 11th kilograms. So as you can see, in a very little amount of mass, there's a whole lot of energy. Alright? So, because you've gained this amount of kinetic energy, the truck has gained this amount of mass. I know that's a weird concept. Well, hey, I'm sure that's flipped you guys out enough for today. I'll catch you on the flip side.